So in this video, I'm going to explain time and space complexity as used in algorithms, determining the efficiencies of algorithms. So time complexity and space complexity, they are used to determine how efficient an algorithm is. So what time complexity says about an algorithm is how much time it takes for the algorithm to run. And then the space complexity, what it does, it says how much space is needed to run the algorithm, depending on the input that is given. So in my own understanding, it's like this. When you look at time complexity, it's like a relationship. Let me try to do this. It's like a relation. It's like a relation. It's like a relation between input and time taken. Time taken to run. That is how space. This is how time complexity is. It's like a relationship between input and time taken. And then space complexity. Space complexity. It's like a relation between the input and the space required to run. And the space required. That's how these two are. So time complexity determines how much time, or it gives you like a visual representation of how much time an algorithm will take to run. Space complexity gives you a visual representation how much space an algorithm will take to run. Now let us do some examples to put this more in depth. So we're going to start with this one. So as you can see this code, you have a variable A, B, then you have one loop and then the second loop. This is kind of like pseudocode. The first loop and then the second loop. Now the question is, what is the space and time complexity of these two? Now if you to look at the space complexity, the time complexity, you'll have to first say, what are my inputs? So I want to find the relationship between input and time taken. So what are my inputs? So you can say my inputs are n and m. Those are the two inputs in which are entering into the program. Then after asking yourself that question, you're going to ask yourself another question. How much computation is taken to run this? So for example, if a program runs once, that is one computation. If it runs twice, that is two computations. So if you have a range of n, meaning 0 up to n minus 1, so this one goes from 0 up to n minus 1, it means that for each number you reach from 1, 2, 3 up to n minus 1, it takes only one computation. It takes one computation. So it means that by the time this for loop is done going through all the numbers, it has taken, by the time it's done, it has taken n computations, right? Now, this for loop, by the time it is done, it has also taken, this for loop has also taken, it has taken m computations. Now, to get the big log of n, to get the big O, the big O notation, not the big log of n, the big O notation, what this notation would be, it will be O of n plus m. N plus n. Now this will be the what? The time complexity it will take for this algorithm. And then the space complexity is, so I want to find the relationship between input and space required. So as input increases, as n increases, or as m increases, the space does not increase. That means that the variable a and b, they don't change. There's no space that is increased, which means that the space complexity here is O of 1. So it goes in constant time. That will be the space complexity. So a for loop, this for loop, it can run in O of n. A for loop can run in O of n, and also a for loop can run in O. It can run in O log of n. So So a for loop can run in either O of n or O of log of n. Let's give examples of how a for loop can run in O log of n. So for a for loop to run in O log of n, it means that if I have an array of 0 to, let's say, 100, and each computation, each point I reach it into, so if I have 0, 1, 2, 3, 4, 5, 6, let's go up to 6, 7, 8, 9, let's go up to 9. So if this is my range from 0 to 9, what does this mean? It means that when I'm at 0, that is one computation. If I'm looping through, that is one computation. I'm at 1, that is another computation. 2, that's another computation. 3, that's another computation. 4, that's another computation. So if I use up all my computations, it means that the algorithm has run in O of n. But for an algorithm to run in O log of n, it means that for me to go through this loop, for example, if this for loop is to run in O log of n, for me to go through this loop, not this loop, for me to go through this loop, but this array, using the loop, for example, for the algorithm to run in O log of n, what has to happen is this. It has to take less time to run through this, meaning that it should go from 0 maybe to 3 to 6 to 9. If it does that, if it goes from 0 to 3 to 6 to 9, it means that this for loop would have run in O log of n. That is for a for loop to run in O log of n. O log of n. Let me give an example of a for loop that runs in O log of n. So for that is the simple basic. That is a simple idea, according to me, of how this how to find out these time complexities. So let's see. Let me get an example here. So let me get this. So let's look for example this, right? First, ignore this for loop. Let's only look at this down for loop. So if you look at this down for loop, what is happening is this. You are starting from 0 up to some arbitrary n. From 2 up to n. So my range would be 0, 4, 5, 6, up to some n value. Up to some n value. So to represent that mathematically, you can put dot 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 up to some n value. So this is my range. So for me to determine whether this loop is running in what time, what I will do, I will say, okay, how am I looping through my input data? How am I going through my input data? So if you look at the way this is going through its input data it is skipping twice at every j. It means that if it starts at 2, the next one will go to 4, the next one will go to 6, and then it will be skipping twice. So since it's skipping twice, it means that this algorithm is taking less time. It means that the time this algorithm is taking, this loop is taking to go through this range, it is less than O of n. It is less than O of n. Which means that if it is less than O of n and it is skipping twice, it means that my big O notation is log of n. That is my big O notation. So this is the time this algorithm is taking to move. So now, if you have two loops, two nested loops, what you do to find the time complexity, you first find the time complexity of the first loop, then find the time complexity of the second loop, then you multiply the two. So the time complexity of this loop is, I'm trying to type faster, my keyboard is kind of hard. The time complexity of this loop is n over 2. Of this first loop, it's n over 2. Why is it n over 2? It is n over 2 because in a range, the range at which this loop is going through, it is looping until, it is moving through the loop until half of the range. And that's why it is stopping. Until when it reaches half of the range, then it stops. So this is why this is all n over 2. So what you do, you multiply this with this. And when you multiply the two, you actually end up with, for that, the big O notation of these two, you'll end up with O n log of n. That's what you'll end up with, O n log of n. So this is how I simply understand this. I understand time and space complexity. Time complexity is simply just try to find the relationship between the input and the time. So what it means that as my input increases, what happens to my time? Does my time decrease? Does my time double? Does my time double exponentially? So for example, this here, as the input increases, the time usually doubles according to the two loops. So you have to multiply the complexity of the first loop and the complexity of the second loop to get the final complexity of the algorithm. So that is it. If the code is in sequential order, if the loops are in sequential order, what you do, the time complexity, you just get the time complexity of the first loop and you add it to the second loop. And if the one that has the larger input is the one that you take, for example, if M1 had a larger input, the time complexity would be over O of M. So in my understanding, I hope I have not confused anyone. I hope it makes sense. That this is my understanding of of how time and space complexity work and how to find them. Yes. So that is. Thank you very much for watching. Have a nice day.